Alright guys, hopefully you're having an awesome day. I'm out with the chemistry team planning a bunch of stuff for you guys. So I wanted to do this with you via video because it's really easy for you to just kind of copy what I'm doing. Feel free to pause the video as needed, and hopefully you can hear my voice okay and it's not too loud or too muffled. So you are working on this today, color coding this periodic table, and if you are in pre-AP, I also want you to complete this phase diagram worksheet. We briefly discussed the phase diagram yesterday, so feel free to refer back to those notes. You can work on this independently or with a partner, but you need me to tell you what I want you to write on your periodic table as notes. So first things first, let's title this the periodic table of the elements. Okay, so the reason I wanted you to do that is because I wanted to point out that every single square on this whole periodic table represents an element. So you will learn more about this tomorrow, but elements are pure substances and they are organized by properties on the periodic table. So you can kind of group together elements on the periodic table and assume you know what their properties are in general. Okay, so there are way more details to this that we will talk about in a future unit, but today we're going to talk about metals, nonmetals, and metalloids. Okay, so what you need to know first is that these groups, or these rows going down your vertical columns, and I'm going to draw a little arrow going down. These are called groups. Come on now, focus. And sometimes you will hear them referred to as families, okay? And they're called families because everybody in this column has similar properties, okay? So vertical columns are groups or families. Same thing. Okay, they are numbered 1 through 18, and we're going to go ahead and do that, although those numbers don't come into play until a few units from now, but I can at least specify which group or which family I'm talking about. So this is family 1. They have a name that we will talk about later. Family 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Several of these groups have very specific names that, again, we will learn in a future unit. Okay, these rows that go across, your horizontal rows, are called periods. Okay, and that's where we get the name periodic table. Okay, they are numbered 1 through 7. So 1, 2, 3, 4, 5, 6, 7. And elements on the same period do not necessarily share the same properties or features. So only elements in the same group do, and it all depends on their outer ring of electrons. Okay, again, we'll talk about that in another unit. So these two sad rows down here are called your lanthanide and your actinide series. This row are your lanthanides. This row is your actinides. We really don't talk a lot about them this year. The reason I am mentioning them right now, well, you do need to know them. You need to know lanthanides and actinides. But I also want to point out that the reason they're like shifted outside of the periodic table is because if they were where they belonged, the periodic table would be seriously long. Like the periodic table on the wall would go from the hood to my door. And that's just inconvenient. So they're shifted down, and you can see where they come in right here. Okay. So I want you, before we start categorizing our elements into metals and nonmetals and metalloids, I want you to draw in these elements right here. And if you need to pause this, you can. If you need to look on the big periodic table, you can. But take a second and label these elements, and then draw a big zigzag line in between them. And it kind of stops there. So all of your elements on this zigzag line except for aluminum, and that is extremely important that you remember that. Aluminum is a metal. Okay, and you know that. You could have probably told me that before you even began chemistry. But every element along the staircase is called a metalloid. Okay, and we'll talk more about them in just a second, but I just wanted to get the structure started. So those are your metalloids. So let's first, though, talk about our metals. They make up a large portion of the periodic table. They are everything to the left of that zigzag line and your lanthanide and actinide series. Okay, so I want you to pick a color, and you can color it in full if you want, but I'll just be outlining. These guys right here, like all those ones on the periodic table on the wall that are white element symbols, we don't really talk about those that often. Like, I honestly don't even know for certain which ones down here stop the metals and which ones start the non-metals. In fact, I believe those, the ones in white, were man-made ones. Like someone just injected a proton quickly and then it disintegrates. So again, the ones in white on the large periodic table you don't need to stress about. So the yellow group, my yellow group are my metals. And I want you to write down some of the properties of metals. Okay, metals are good conductors of electricity. Whoopsie. They are mostly solids at room temperature, except for this one little guy, Hg. I don't want to do him in blue because I'm going to do my nonmetals in blue, so I'll just do him in black. Hg is mercury, okay? He is the one metal that is liquid at room temperature. That's what they used to put in thermometers, but mercury is a pretty heavy metal and quite dangerous, so they don't use that in thermometers anymore. Some other notes that you need to write about metals, some properties of metals that you will need to know and you will be tested on, is that they are malleable. Okay, malleability means it can be rolled or hammered into sheets. Ductile, that means it can be made into wire. High tensile strength, Okay, that means that they can resist breakage when pulled. Sorry. And then most have a silvery or grayish white luster. Okay, so make sure if you need to pause this, you can. You need to write down these properties of metals, and you need to know what these properties mean. Malleability is rolled or hammered into sheets. Ductile is pulled into wire. High tensile strength means they can resist breakage. They are good conductors of electricity. That's why they use like copper wiring in our homes. And they are solids at room temperature except for mercury. Okay, those are your metals. I am going to outline the non-metals in blue, and they are your group of elements over here. Again, I'm just going to kind of ignore those ones on the bottom that are white. They're a smaller group. They are your top right-hand corner of your periodic table. Okay, these elements are poor conductors of electricity. Many are gases at room temp. And some are solids at room temp. I'm running out of room. And I'll give you a little cheat code. If you look on the periodic table on the wall, any element that's written in the color black, those are your solids at room temperature. Any element written in the color red, those are your gases at room temperature. And then you can see mercury, Hg, is blue because we discussed him being a liquid at room temperature. And your last element that is a liquid at room temperature is bromine. Okay, he's a liquid at room temperature. This last column, column 18, this family is called your noble gases. They are nonmetals, but they don't react like nonmetals. Okay, we'll learn more about them in another unit. Okay, so the last section of elements that I want you to take notes on is the red section that fell along this zigzag line. Remember, everyone except aluminum that touches the zigzag line. These are called, where should I write this? Here. Metalloids. Okay, so all elements on zigzags, I will call it the staircase sometimes, except aluminum. And you guys know aluminum is a metal. They have some characteristics that are metallic and some characteristics that are like the nonmetals. Okay, so they're kind of wishy-washy. Share properties. Oh goodness, my lights went off. They share properties with metals and nonmetals. I'm going to abbreviate nonmetals NM. Okay, they are all solids at room temp, and they are semiconductors. Okay, semiconductors of electricity. So feel free to go back at any point that you needed to get more notes. I will put this key on It's Learning. The substitute also has this key available if you can't hear me or you can't see what I'm writing. So hopefully that all makes sense. I hope that you guys are having an awesome day. Don't forget to return and do the phase diagram worksheet if you have not already. And when you are done with that, you are free to work on homework from another class, or read or study those things that you just learned in here. This is what we're going to start tomorrow. We're going to start classifying matter into pure substances or mixtures. All right, talk to you later. Bye.